Bright QT. Every student matters.
Now we will be taking up a few numericals based on the circuit diagrams. When we are talking about circuit diagrams, right, there are a certain steps that you need to follow, steps to solve numericals based on circuit diagrams. There are different ways in which questions may be asked. We will be discussing it one by one. Initially, we are talking about the first type of questions. The various types I will be discussing as and when we will be proceeding further. Now, the various steps that we will be following is, first of all, always calculate. We need to calculate total resistance of the circuit. We will be calculating total resistance, that is capital R of the whole circuit. We will be given some individual resistances, we will be calculating the total resistance. Got it? After finding the total resistance, what now second step says is, out of V total potential difference and I total current, one will be given in question, of course, always directly or indirectly. One will be given in question, we will find the other. The next we will find using Ohm's law. We will be using Ohm's law to find that, and Ohm's law we know that V is equal to IR. R we have found out in first step. Out of V and I we are saying that one will be given in question. So, if out of these three things, two things are given to us, we can easily find out the third one. Got it? Now, after this, what we will use is utilize the is equal to value. Now, is equal to value means, let us remind us, in series we know that I is equal to I1 is equal to I2 is equal to I3 and so on, whereas in parallel we have V is equal to V1 is equal to V2 is equal to V3, right. Out of these two, depending upon whether it is a series setup given to us or a parallel combination given to us, we will utilize this particular identity and use the equal to value and find the remaining values. We will find the remaining values once again using Ohm's law, which state that V is equal to IR, or V1 is equal to I1 into R1, or V2 is equal to I2 into R2 and so on. V3 is equal to I3 into R3 and so on. These are the simple basic three steps we need to follow. How? I am telling you, don't worry. Fine. Let us see how. Now, I am given a question. I am given a circuit diagram like this. I am given three resistances which are parallel to each other, fine, and they are connected to a cell, a key plugged in, fine, plus minus current direction. Now, in first question we are given over here 12 volts. I am given first resistance value 5 ohms, second resistance value 10 ohms, third value is 30 ohms, maybe any, alright. Okay. Now, try to relate, this is quite important now, try to relate please. this 5 ohm I am considering it to be R1. This 10 ohm I am considering it to be R2. This 30 ohm I am considering it to be R3. Got it? Now, very importantly, the current in the 5 ohm resistance is represented as I1. The current in this second ohm resistor is I2 and in this third is represented by I3. Similarly, quite importantly, the potential difference across first resistance is given as V1 or V2 in second, V3 in third. Got it? The total potential difference is this capital V. The total current in the circuit will be capital I. The total resistance will be capital R. Right? So, in this particular circuit diagram, what all possible values can be found out are the total potential difference, the total resistance, the total current. Right? Apart from them, if we are talking about individual resistances, then potential difference in the first resistance, in the second and in the third, first resistance value, second resistance value and third resistance value, first resistance current, second resistance current and third resistance current. These are all the possible values that can be checked out or find out in this particular circuit diagram. Out of these now, we may be asked to find anything. For example, in the question, we may be asked to find the total resistance of the circuit, that is capital R, or the total current in the circuit, or we may be asked what will be the amount of current in 5 ohm resistance, that is he is asking I1. What will be the current in 10 ohm resistance, he is asking I2, or similarly 30 ohm resistance, he is asking I3. Right? Have you got it? Fine. So, these are all the things which may be found out. Now, out of these, let us see what exactly are given to us. Let us circle them. We are being given the first value of resistances R1, R2 and R3. We have circled it, that means it is given to us. We can see 5 ohm, 10 ohm, 30 ohm. Right? This 12 volt is the total V given to us. Right? Apart from that, we are not given anything. Let us find and calculate everything. Right? We have practice. First of all, the first step, as I have told, the first step while doing these type of numericals, that is basically by calculating total R. So, when they are in parallel, how I am going to calculate total R? Let us see. This is my first step. In parallel, I know that total resistance is given by the formula 1 upon R1 plus 1 upon R2 plus 1 upon R3. Got it? Fine. So, 1 upon R will become 1 upon 5 ohms plus 1 upon 10 ohms plus 1 upon 30 ohms. Taking the LCM to be 30, let us see 6 plus 3 plus 1 comes out to be 6 plus 3 9 plus 1 10 by 30, that means 1 by 3, and taking the reciprocal R comes out to be 3 ohms. This is the total resistance. Let us circle it, that now we have found the total resistance. Got it? If you are being asked calculate the total resistance, this is the end of your question. Right? You have just found out total resistance, that is it. But if the question still asks you or demands you something else, let us proceed. Second part, if we are asked to calculate the total current. So, now what did our second step that we have written earlier said that out of V and I, one thing will be given to us, second thing we will calculate using Ohm's law. So, Ohm's law state V is equal to IR. We need to write in bracket what exactly is because of, this is because of Ohm's law. Fine, right? So, V, the value is given to me to be 12 volts, R I have already calculated above 3 ohms, then I will easily find out the value of I. So, I becomes V upon R. V is 12, R is 3. So, I comes out to be, cancelling it out, 4 amperes. So, now I have got I circling it. So, this is the second part in the question that you may be asked, calculate the total current in the circuit. So, if this is asked, calculate total current and total resistance, this is the end of our answer. But if he further inquires, calculate the individual currents. Let us see. Now, for calculating the individual currents, now I will be applying my third step, that was, you remember, making use of the is equal to item. I know that in parallel combination V is same, V is equal to V1 is equal to V2 is equal to V3. So, if the total V is 12 volts, in that case the V1, that means in 5 ohm resistance the V will be 12 volts, in 10 ohm also the V will be 12 volts, in this also the V will be 12 volts, because V1, V2, V3 are same in parallel, right. So, now I knew this values V1, V2, V3, circling them up, right. I hope now it is crystal clear how you are going to calculate the individual currents. Again, using our own Ohm's formula, that is V1 is equal to I1 into R1. So, I will get I1. What will be I1? I1 will be equal to V1 upon R1. V1 is given to be 12 volts, divided by R1 is 5 ohms. I will get 12 by 5. Similarly, I2, I will be getting I2 will be equal to V2 upon R2, that comes out to be 12 by 10. I3 will be equal to V3 upon R3, which comes out to be 12 by 30, and I am calculating these currents. So, my answer will be in amperes. So, these are now the values of all the individual currents. Students, we will not be asked to calculate all these values in the question. We will be just simply asked as to what is the current in 5 ohm resistance, or what is the current in 10 ohm resistance, or what is the current in 30 ohm resistance. So, you will be asked to find either I1 or I2 or I3, whatever thing he is asking, we may easily just calculate. So, now I have circled everything, that means I have calculated every possible value in this particular question. Got it? This is how simply we follow these basic simple steps and we calculate the values given to us, right. Now, there are many numerical questions that you need to practice in order to get a bit command. We will be taking a few questions, a few examples, because that is required. Fine. Let us say. Now, the next type of question that may be given to us in the examination is maybe possibly how? Simple one. We are given this is the first resistance, this is the second resistance, and they are connected to a battery or a cell. How much is the value? Probably we are not being given. This is a plug key switched on, the current is flowing. Now, this value, this is R1 given to us to be 5 ohms, fine, and we are given that a potential difference of 10 volt is applied through it. Clear? In this particular resistance, this is our second resistance, the potential difference is given to be 6 volts. Got it? But we are not given the value of this particular resistance. What he will be asking in the question is, number 1, he is asking calculate the current through 5 ohm resistance. This is the first thing he is asking us. Second thing, he is asking calculate the current through the second resistance, the value of which is not given to us, R. Third, he is asking us to calculate what is the value of R. And fourth thing, he is asking what is the value of V, means total potential difference. Now students, try to relate. This is, this is the first resistance, this is second resistance, right. This is potential difference in the first resistance V1 given to us, this is the potential difference in the second resistance V2 is given to us. Rest nothing else is given. Now just try to follow what all you have learnt till now, right. Very important. Let us first of all, before doing this question, let us first of all review what all we have studied. We have studied these two things that will be applying now, series and parallel combination. Now this is very important students for attempting all the type of questions only, and when I am saying only, then I am actually meaning it, only these concepts are required that are going to be written on this particular page. Try to just keep them in your mind, try to understand and relate, because we will be using only these four concepts throughout. Just we will be observing, we will be just molding the things up, and except these nothing else is going to be used. In series, first thing is total resistance is calculated by the formula R1 plus R2 plus R3 and so on, whereas in parallel 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. Now in series, quite importantly, the current is equal to the individual currents. But in parallel, it is not the case. In parallel, I have got I is equal to I1 plus I2 plus I3. Now, when I talk about in series, potential difference is equal to V1 plus V2 plus V3. But in parallel, V is equal to V1 is equal to V2 is equal to V3. These three things you need to keep in mind, and apart from that, the fourth common thing that we will be relating is V is equal to IR, which can be written as I is equal to V upon R or R is equal to V upon I anyways. And if I am talking about V is equal to IR, I mean to say V1 is equal to I1 into R2, V2 is equal to I2 into R2, V3 is equal to I3 into R3 and so on. All these four things, that is it. Now try to utilize in the actual question that we were attempting. In this particular question, I am given R1 5 ohms, I am given V1 10 volts, I know V and R, so I can easily calculate I using Ohm's law. So what I will do is, I will calculate I1. I1 will be given by V1 upon R1 as per Ohm's law. V1 is given to be 10 volts, R1 is given to be 5 ohms. Cancelling it out, I will get the value of current to be 2 amperes. Now I know that the current in this particular resistance is 2 ohms, right? Got it? Now quite importantly, again I know that these two resistances R1 and R in series, they are in series, and in series what is same? I1 and I2 and I will all be same. So if I1 is 2 amperes, obviously the current in this resistance, that is I2, will also be 2 amperes. You see, this is how I am going to apply the things. And since now the current we have just seen 2 amperes, potential difference V2 is given to be 6 volts. Now I can calculate R. How? By using same Ohm's law. R will be given by V2 by I2. V is given to be 6 volts. Current is 2 amperes. Cancelling it out, it will be 3 ohms. So now this R is equal to 3 ohms. See, so simple. Now I am given this resistance to be 5 ohms, this resistance to be 3 ohms. In series, I know that the total resistance is given by the sum total. So, the total resistance will become 3 ohms plus 5 ohms is equal to 8 ohms. This is my total R. Got it? Total R given to be 8 ohms. Total current I have found out 2 amperes because I1, I2, I will be same. Now, what is left? Calculate the value of V. V is equal to IR. I is 2 amperes, R is 8 ohms, comes out to be 16 volts. Got it? Now, see what all we have calculated one by one. Current through the 5 ohm resistance. First of all, I calculated through this 5 ohm resistance, the current was 2 amperes by the formula I1 is equal to V1 upon R1. Then I calculated current through R. In this R, the current will be same, that will be 2 amperes because I1 is equal to I2 is equal to I. Got it? Then what is the value of R? I just found out the value of R because now I already know I and V, I can calculate R very well. Next, the value of V I just calculated. By calculating R, I will calculate the total resistance. The total resistance is just calculated. Current we have already calculated. I will apply Ohm's law and I will put up the value and I will get the desired answer. Got it? So, this is how we attempt these type of questions. Got it? Once you will do it, you will love these questions. They are very good, they are very nice questions and you will tend to do more, right. Let us see the next type of question. Let us a bit make it seemingly complex, but not actually. I am given a figure like this. These are the few resistances given to me. Sir, what are you doing? The marker is in your hand, doesn't mean you are going to make as many resistances as you feel like. They are very simple actually. Seemingly the figures may be a bit frightful to you, but once you know how to do it, just like with the click of the hand you will do it. Now, I am given 10 ohms here, I am given 40 ohms here, I am given 30 ohms here, I am given 20 ohms here and 60 ohms here. This is my 12 volt battery plus minus, I can just pass on the current. What exactly is being asked in the question is calculate total R. Of course, that is the first requisite. Even if he is not telling us, we have to calculate as per our concepts. Second thing he will ask us is to calculate total I, total current in this circuit. Any idea how to do it? Obviously, let us see. Let me do some work for you. Now, as per this figure, what we can observe is these two resistances are in parallel, right. So, first of all, what we will do is we will combine these two resistances and we will take a single value. Let us see how. Do you want to give them a name? Alright, let it be R1, R2, R3, R4, R5. These are the 5 resistances given to us. Fine. So, when I will be calculating now the combination of these, first thing is I cannot use capital R. Why? Because capital R will signify the total resistance. So, for making the thing simpler, till 5 I have got, I will take the combination to be R6. This 1 upon R6 will be equal to the sum total of R1 and R2 in reciprocal, as we know that they are in parallel. So, it will be calculated like this, taking the values 1 upon 10 ohms plus 1 upon 40 ohms. I will be taking the LCM 40. Now, this will become 4 plus 1, that comes out to be 5 upon 40, cancelling out 1 by 8. This is 1 upon R6. So, I will be taking the reciprocal, that comes out to be 8 ohms. So, now instead of this setup, what I can do is I can simply make a single resistance that is the combined value of 8 ohms. This was my circuit, alright. Now, the same thing I will do is with these 3 resistances. These are 3 resistances connected in parallel. So, if I take a combined value, that will help me out in giving my answer. Let us see. One is 30, 20 and 60. Let us remember, because we are going on the next page, 30, 20 and 60. So, now I will be calculating 1 by R7. Why this R7? Do I need to tell you? No. R6 we have calculated till now. 1 upon R7 will be equal to the sum total of 1 upon R3 plus 1 upon R4 plus 1 upon R5. Let us go to the previous figure, so that you are able to relate. This was R3, R4, R5, and that is what I am taking the total of. So, putting the values 30, 20 and 60, I will get 1 upon 30 plus 1 upon 20 plus 1 upon 60. LCM I will be taking 60, right. Students, there are times when I really assume that you are in 10th class. So, this LCM taking part, this is clear to you, right? Good. So, this should be clear, okay, because I am not taking a mathematics class, and I hope that you are already through with all these facts. So, directly solving it up over here, I will take 2 I myself I am making the error, then this is 3 and then this is 1. So, what I will get is 3 plus 2 5 plus 1 6 upon 60, cancelling it out 1 upon 10. So, this is 1 upon R7, R7 will be taken to be the reciprocal. So, this will be 10 ohms, right, fine. So, now instead of drawing this particular figure, what I will take is, I will take a combination of these 3 and the combination comes out to be 10 ohms. Now, this was my R6, this is the R7 that I have calculated. Now, the diagram has been very simple, and we see that this R6 and this R7 are in series now. So, if I will be calculating the total resistance, now the total resistance will become R6 plus R7, which will be 8 plus 10 is equal to 18 ohms. So, this was the first part of the question, calculation of total R, that is 18 ohms. Got it? After 18 ohms, after calculating total R, what I am supposed to calculate? Total I. Total V I am given in the question 12 volts. So, I can relate as per Ohm's law, V is equal to IR. Therefore, I is to be calculated, I will become V upon R. V is 12, R we have just calculated 18, this will be our I. Just putting it out, 6 to the 6 3 the, we will get the value 2 by 3 amperes. This is our total current flowing through this circuit. Right, students? Now, seemingly interested, seemingly good questions, huh? Of course, they are, provided you do them properly and you do them thoroughly. They are very good questions, very simple questions, very nice questions. You will love them when do well, you will do them on your own. Let us take a few more questions which are a bit different. I will not say difficult, but they are a bit different, right. How different? Let us see. Okay. Now, this is quite important question. This is a 3 marker. This has come lot many times in examination. Please try to relate. Two resistances when connected in series give a resultant of 9 ohms, and when connected in parallel, when these two same resistances are connected in parallel, give a resultant of 2 ohms find the value of these two resistances. We need to find the value of these two resistances. We are not yet given the values, but what we are given is there are two resistances, don't know the values, right. If we connect them in series, we will get total R to be 9 ohms, and if in parallel, we will be getting a total R of 2 ohms. Fine. And since we are not given the resistances, what we will do is let the two resistances be X and Y. Let the two resistances be X and Y. Fine. Now, as per the question, when these resistances are connected in series, then the total R is given out to be 9 ohms, and when they are connected in parallel, the total R is given out to be 2 ohms. This is what is given to us in the question. Now, let us see how we are going to make utilization of it. Now, in series, I know that the total R is given out to be R1 plus R2, right. The total R is given out to be R1 plus R2. Fine. R1 I am not given, I have taken the value to be X. R2 I have taken the value to be Y. Total R is given to me to be 9 ohms, right. So, I can write X plus Y is equal to 9 ohms, or I can say that X is equal to 9 minus Y. This I will keep out to be my equation number 1. Got it? Now, second thing, this is first I have got. Second thing, in parallel combination, we know that in parallel 1 by R is given out to be the sum total of 1 by R1 plus 1 by R2. The first resistance is not given to us, I have taken the value to be X. The second resistance I have taken the value to be Y is equal to 1 upon the total R in parallel is given out to be 2 ohms. Now, students, the most important mistake that students tend to do is they write 2 instead of 1 upon R. It is not 1 upon R that is given out to be 2 ohms, it is R that is given out to be total resistance that is given out to be 2 ohms, right. Now, this becomes my equation number 2. Now, I will just simply put the value of X from equation number 1 in equation number 2. I will form it in the form of a linear equation, and I will just calculate the value of X and Y. How? Let us see. The most important part was just to relate in series it is given out to be 9 ohms, in parallel R is given out to be 2 ohms. So, it will be 1 upon 2, not 2. Let us see, by putting the values, I have seen that 1 upon 2 is equal to 1 by X minus 1 by Y. Now, putting the value of X from equation 1, what we get? We get 1 by 2 is equal to 1 upon, instead of writing X, I will be writing 9 minus Y minus 1 upon Y. Oh, minus, it should not be, sorry, it is plus. Fine. So, 1 upon 9 minus Y plus 1 upon Y is equal to 1 upon 2. Now, simply I will be taking up the LCM. Over here, the LCM will be 9 minus Y multiply by Y. Here, I will take Y plus here I will take 9 minus Y. Cancelling it this Y with Y, I will get 1 upon 2 is equal to 9 upon 9 minus Y multiply by Y. Opening up the bracket, what I will get is 1 upon 2 is equal to 9 upon 9 into y is 9y minus y into y is y square. Now simply cross multiplying, I will get my equation to be 9y minus y square is equal to this I am bringing here, this I will be bringing here, 9 multiplied by 2 should be equal to 18. Got it? Now taking all the things on the right hand side, what I will get the equation to be, this will be 18 minus 9y, because 9y when comes here become minus, plus y square, because y square when comes here becomes plus, is equal to 0. Now this is my equation. I will simply do the midterm splitting. I will take such values whose sum should be equal to minus 9 and the product should be equal to 18, and those two values I will be taking up. 0 is equal to 18 minus 6y minus 3y plus y square. You see, minus 6 and minus 3. The sum total of these is minus 9, and minus 6 into minus 3, the product will be equal to 18. Now taking common, I will say I will take 6 common here, I will get 3 minus y, right, fine, minus y I have taken common there, 3 minus y. So what it becomes, 0 is equal to 6 minus y or 3 minus y. So this leads me to either 0 is equal to 6 minus y or 0 is equal to 3 minus y, which gives me the value either y is equal to 6 or y is equal to 3. These are two possible values I will get of y. Now as per our equation number 1, we saw that x was equal to 9 minus y. So if I will take, if y is equal to 6, then x will be equal to 9 minus 6, that is 3, and if taking this possibility y is equal to 3, then x will be equal to y minus 6, y minus 3 will be equal to 6. So we find that the first resistance is of 6 ohm and the second resistance is of 3 ohms, because x and y we have taken to be these two resistances. Now as per the question, we saw that these two resistances when connected in series, the first resistance was of 6, second is of 3, you can take 3 or 6, both are same, one or the same thing, right. The total resistance will be 9 ohms, and if they are taken in parallel, one is 3 ohm, one is 6 ohm, you can just change it also, the total resistance you will calculate will be of 2 ohms. So this is how we get our answer, just simply converting it into a linear equation. So the answer, the two given resultant resistances are 6 ohms and 3 ohms. Got it? Fine. So this is a very important question. Just try to practice all these questions. I hope you have understood till now. There are few further questions, a bit complex ones. For that you need to first of all prepare, go through them all these, try to do it with your own hand, try to practice it. Fine. Thank you very much.